Arr! And welcome, mateys, to another edition of Math with the pirate, Mr. Douglas. Yes, today we are not going to be going and finding X pirates. Get it? Today we are going to be looking at polygons and trying to find the inside angles and the outside angles of polygons, and also defining a bunch of terms. All right, let's get to it. Off we go. Is that what pirates say when they set sail? Here we go. We get to start off this lesson with my favorite math joke. Yes, math jokes. Jokes are awesome. What do you call a bird that flies away on a pirate ship, on a math pirate ship specifically? What do you call the bird that flies away on a math pirate ship? Well, of course, you call that bird Polygon. Polygon? Yeah, that's right. I'm expecting you're all laughing and telling your friends about this amazing comedian. We call it Mr. Douglas, who does math occasionally. So, speaking of math, today we are talking about polygons. And polygons is pretty interesting. The word poly comes from the Greek words to mean many, and then gon, just G-O-N, like that, just in Greek means angle. So we're talking about many angles. And if you're kind of figuring out, like, so what is actually a polygon? So the kind of the definition is it has to have straight sides. So there's no curves allowed, and straight angles. And it also must be closed. So you couldn't have like this. So straight, 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 but it's not closed. Then it's not going to be a polygon. And there are lots of other things that we need to know for different words. You have regular polygons. And a regular polygon just means that everything is equal. So there's equal length sides. So those are regular ones. These are when you're thinking about like your pentagon, right? So every side is the same length. And none of my drawings will be drawn to scale today. So like a pentagon, that's a horrible looking pentagon. All equal sides and that kind of stuff. What other kind of things do you need to know about? If a polygon is simple, or is it complex? Is it simple or is it complex? Basically, if a polygon is complex, it crosses itself. It crosses. It doesn't mean it argues with itself or get upset. It crosses. Think of a star. See, everything is straight, everything is closed, but they cross each other. Whereas a simple polygon would just be like this, boom, like that. Speaking of polygon, of course, we're talking about 2 dimensions, and also, let's go and add in here, it must have at least 3 sides. 3 sides or more. Okay, now some other stuff we're talking about is convex or concave. I'm going to get rid of the jokes here. Convex or concave. So convex. And we also have concave. And basically, if you have a convex, there's no inward pointing angles. There's no inward. And no internal angles are more than 180 degrees. No internal, the inside angles. So no internal angles are greater than 180 degrees. And for a concave, just think about the word cave. So you really want to think about the word cave. So something is kind of like punching it in. And the external angles aren't greater. So let's just say no external angles. Let's just bing, 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 bing. There we go. No external angles. So no external angles are greater than 180. Let's take a look at a picture, because a picture is going to be worth 1,000 words, as they say. Let's get green. I think I need a little bit more room here. I'm just going to erase this right here. And erase this. There we go. The magic of pictures. So concave. So you're looking at a concave, like it's been boom, There's like a cave there. It's been punched in, like that. And then a convex would be something like this, like that, convex. And there you go. You also have external and internal angles. So this is one that always seems to get kids. So I'm just going to draw so we're looking at internal and external angles, and this is going to lead into some formulas that you guys are going to need to know. So I'm just going to try and draw, try being the key word here, try and draw this pentagon. And maybe we'll use this pentagon to talk about a lot of different things. So there's my pentagon, and I'm going to go and draw the external angles. So I'm going to just extend these lines. So this is the external angle, and then this part here. So I'm kind of like making like a throwing star. This goes back to like the 1980s Bruce Lee, Chuck Norris movies. Chuck Norris is awesome. Never mess with Chuck Norris. There's probably some Chuck Norris jokes out there for math. You can leave some in the comments, I guess. Maybe you're thinking I knew some of them, but I don't. Okay, so those are the external angles, those blue things. So the external is the blue stuff. And then the internal, so the internal angles, the inside stuff, which I think is, you guys all know that one. So those are the internal ones. Now, we can go and figure out, pretty cool, for any kind of polygon, what the internal and external angles are going to be. So here's the formulas that we need to know. So formulas, formulas, and the first one, so the very first one is the sum of the interior angles. The sum of the interior angles. Sum of the interior angles of any polygon. And we'll say it's n-sided. So if we're looking at the inside, so this formula, I'll write it in green, it'll be exciting, is going to be n, and n is the number of sides, minus 2 times 180. Times 180, and that we're talking about degrees. So let's take a look at this example. So this example here, we have a pentagon. You maybe already know this one. How many sides does a pentagon have? 5. Right, there are 5 sides. So we're going to go just 5 minus 2 in brackets, then times that by 180. So basically 3 times 180. So that would equal 540 degrees. So the internal angles are 540 degrees. That's excellent. But now let's kick it up a notch. Bum, 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 bum. So that's how much it is in total. Remember, the sum. But what about each one? If I wanted to know each one, well, then what would you go and divide that 540 by? You would go and divide it by n. So if we want to know the different sides, you divide it by the number of sides. So n divided by the n again. So for us, we would go and we would just basically say that 540. So I'm going to go and do that 540, because I know that's 540. I'm going to divide it by 5. So each of those angles is going to be 108 degrees. So that's what we're talking about, the inside angles. So how much they are in total, also how much they each are individually. And kind of staying with that kind of theme, we can stick around with our pentagon. So here's another attempt at drawing a pentagon. That's way off. What about the external angles? So remember, we quickly talked about the external angles, and we're talking about these sorts of things. Well, how much does the exterior angles of any polygon equal? Well, the external angles are equal to always 360 degrees. Well, that's pretty cool. So how do you know how much each one is? How much is each? Can you think of a formula that would go and do that? You would just go 360 and divide it by the number of sides. So for this one, this would have to be just 360, and I would divide it by 5 sides. So I think that would give you 72? Am I right? 72 degrees, I think. 72 degrees. So that means that this external angle, and all of them really, are all 72 degrees. So those are the formulas that we need to know, and we're going to help us go and solve some questions. Now, before we kind of get to that, we do need to talk about a little bit more some vocabulary stuff about how to go and talk about polygons. And kids always love to say, like, what if a polygon had like 1,000 sides? Well, if it was 1,000 sides, I'd want you to think of a snowman. What? But you said a polygon only has straight edges. Well, that's true, but, and maybe this is Olaf. Did you know Olaf likes warm hugs? And I usually want, there we go. There's Frosty or Olaf, depending on what kind of generation you're coming from. So 1,000-sided polygon is actually called, and now this will all make sense, it's called a chilyagon. Chilyagon. I guess you could say it's pretty cold. And the key, I can hear you laughing. The key part here is of course, the gon part. So that's going to be the kind of we're having phrasing, that kind of stuff. But here's the basic rule. From up to 12 sides, so from 3 to 12 sides, you should know the words. But from 12 onwards, you can just use the agon. So for instance, if you had something that was like 19 sides, you'd say a 19 agon. But if you want to go in and impress your your friends, you want to drop this in a conversation, say like, what is a megagon? A megagon, of course, has 1,000,000 sides. 1,000,000 sides. And the googleagon, a googleagon is 10 to the power of 100. And that's just crazy numbers and that kind of stuff. So we're talking about agons, so gons. So that's kind of what we're saying. We're talking about that. So let's go and do some questions. Now that we've kind of talked through what everything sort of looks like. So what are your teachers going to be asking you guys? So here's an example. So whoops, here we go. So here's an example. If I told you each exterior, and I'm going to abbreviate exterior like that, exterior angle is 40 degrees. So every exterior angle of a regular polygon is 40 degrees. How many sides? How many sides does it have? Okay, so we know that the exterior angles are 40 degrees. And so what are you going to be doing? Well, think about the formulas. So remember, we're talking about exterior angles. They're always add up to 360. And you divide it by the number of sides, and that will give you how much each one is. So we know that it equals 40 degrees. We know that. So I'm just going to go and just put this over 1 just to make this kind of obvious. And when you see this now, hopefully you're kind of thinking like, oh my gosh, is this cross multiplication? It absolutely is. So you'd go and you'd cross multiply, right? 40 times n, so you get 40n, and that would equal to 360. So you divide both sides by 40, so n would equal 9. So how many sides does it have? It has 9 sides. Yay. 9 sides. And of course, a 9-sided polygon is called a nonagon. A nonagon. Bet you didn't know that one. Maybe you did. Maybe you did. That's pretty cool if you did. Let's take a look at some other stuff. So you're trying to get the idea. We can use some basic algebra and then start using some other examples. So here's a picture of the top of a 10-sided, so a decagon. Here's this. So imagine this is just the top part of it, just the top. And I just want to know this. So this is a 10 sided polygon. This is just the top part of it. And I want to know what x is. So I want to know the internal angle. So the interior angle of what it would be, of a 10-sided kind of thing. So we would be using the n minus 2 times 180. Now divide it by the number of sides. So what are we going to go and plug in there? We're going to plug in 10 because it's a 10-sided. I'm going to plug in 10 here and plug in 10 there. And this is, I should say this is regular, right? So everything is going to be equal. That's really important. So here you get 8 in brackets. And then you have to go 8 times 180. So 8 times your 180, which gives you 1440. Yes, I just use a calculator for that because it's way too early in the morning when I'm filming this right now. So 1440. And I'd also divide it by 10. That's the number of sides. And you have 144. So this x would be 144 degrees. So these are the kinds of questions you're going to be going and using those basic formulas and applying it to all types of polygons. Hope you enjoyed. Thanks everyone for tuning in for another edition of Math with the Pirate Mr. Douglas. Until next time, be safe out there on the high seas. Arr!